is about cracking of hydrocarbons. And the first bit says that they're taking this decane and they're forming butene, but they want us to work out the values of X and Y. So remember, here you've got 10 carbons. So if we just list for carbon, there's 10 at the start. We've got 4 left over. So that means we are 6 missing. So X must have a value of 6. And Y, so hydrogens, it started off at 22. We've got 8 of them in here, so take away the 8, and that's going to leave me 14 missing. So here I'm going to put 14 down as my answer for Y. State formed. So here, if you've conservation of mass, if you've got 25 of the reactants, then you're always going to have 25 of the products formed as well. So this will be 25, and that'll be grams. Okay, here's the structure. We've got a dot and cross diagram. Complete the diagram to show the double bond inside here. So what we need to do here, remember that a covalent bond is a showing of 2 electrons, but if we've got a double bond, then that's going to be 4 electrons, remembering that they have to be dot and cross. So if I'm doing this one, I'm going to put in here a dot and a cross and a dot and a cross to show that there are 4 electrons, 2 bonds being used in there, and it's only 1 mark, so 1 mark to get that completely right. Incomplete combustion, if you remember what that means, that is a limited supply of oxygen. A limited supply of oxygen. Give the name of another product formed. So we're getting carbon monoxide, could be one of them. So we could get carbon monoxide. You could also just say you could get carbon. You have to get one of them for the mark in there. Right. How does this substance show it's unsaturated and a hydrocarbon? So it's unsaturated because it contains a carbon-carbon double bond. So here, let's put that down first. So it contains a carbon-carbon double bond, so that's an alkene. And the reason it's called a hydrocarbon is because all the atoms are hydrogen or carbon. So it only contains hydrogen and carbon atoms to get, there's 2 marks for that. Okay, next we've got 2 liquids, hydrocarbons, and we're testing them with bromine water. One hydrocarbon has been alkane and one is an alkene. Remember, if it's an alkene, it's going to have a double bond. If it's alkane, it's just single bonds. Each one is shaken with a few drops of the bromine. The results are shown below. So A, with the bromine water, the mixture has turned from orange to colourless, and B, the colour has remained, the orange colour has remained. So what we need to say is explain these results. So the reason that A has done what it's done is A is an alkene, and because it's an alkene, it is going to react with the bromine water. It's an alkene, it is unsaturated, and reacts with the bromine water. Okay, B is an alkane, therefore it is saturated and does not react. Okay, not showing any marks available here. Let's have a quick look. It says 2 marks, so you're going to get 1 mark. I'm guessing you could just argue for A. So if you say it's an alkene, it's unsaturated, that's going to get you the mark, and it's going to react with the bromine water. Or you can argue that B is an alkane and it's unsaturated, therefore it doesn't react.